All right, so it's January 14th, Monday, 7th grade math. We're looking at lesson 69. Tonight your homework is to do written practice 1 through 30, practice set, all of them. And know that we will have a quiz tomorrow on stuff from lessons 65 through 69. It's all free game. Make sure you look it over and learn it. If you have any problems or questions, come in during lunch to go over any of your homework, to go over any questions you have. Our test for lesson 70 will be on Wednesday, or after lesson 70, which will be Tuesday, so the test will be on Wednesday. All right, so now we're talking about proper forms of scientific notation. As a refresher for you, you should remember that, I don't know, I'm getting this alternate sign. That's crazy. It shouldn't be there. You should remember that for scientific notation, it needs to be a number. Scientific notation, the number when we write it is going to be greater than 1, but less than 10. So for example, scientific notation, the number is going to look like if we had the number 25 and we wanted to put that in scientific notation, you remember we have to move that decimal that's kind of understood to be right here, right? We have to move it to a place where the number is going to be greater than 1, less than 10. So if I move it right here and put that decimal right there, I've now made the number 2.5. I've made the number now from 25 to 2.5. So now it's greater than 1, less than 10. But, so I have 2.5. Now I have to account for where I moved it. So I put down times 10, and I moved it one spot to the left. So I'm going to account for that one spot. And I'm keeping it as a positive 1 because to move it back to its original place, to show me what the number is supposed to look like, I have to go to the right one direction, which is positive, correct? So because of that, I want this to be a positive 1. So if I see 2.5 times 10 to the first power, to put that into standard notation, I would move this decimal place one place to the right, which is going to now give me 25, which is what I started with. And that's the proper way of showing scientific notation. Does everybody understand that? Is that confusing anybody? What don't you understand? Okay, what part of it don't you understand? Okay, so you don't see how I had 25. The decimal point was right here. Even though it's not there, we know it's there, right? So I know that for scientific notation, the number has to be greater than 1 but less than 10. So that decimal place, that decimal point has to go right there. It has to go there. So I've moved it one place to the left. So now my new number is 2.5. Scientific notation always has a times sign, a power of 10. Then it's going to have an exponent. And that exponent's going to be a 1 because I'm saying that I moved it one place. You understand, Jamie? I moved it one place. And then it stays a positive 1 because when I want to put it back to its original spot, I'm going in the positive direction one place. Therefore, it's going to be a positive. It's going to the left. It's going to the right one spot. Everybody get that? Understand that? Everybody see that? Does that make any more sense this time, Jamie? Kinda? What's going on here? Why is this not working right? There we go. All right. So let's take this a step further and add a step to it. Let's say that we have the number 25 times 10 to the negative 5. And it wants us to put this in the scientific notation. So we want to put it in scientific notation. the very first thing I have to do to put a number in scientific notation is to make the number, which is this number right here, greater than 1 and less than 10. So does everybody understand and agree that even though we don't see it, there's a decimal place right here for 25? There is a decimal place there. We don't show it because we don't need to. It's still a whole number. Whether it's 25 or 25 point, it's still 25, right? So the number is there. Everybody understand that? Jamie, you understand that? Okay, so to put this number in scientific notation, I have to make this number 25 greater than 1, less than 10. How do I do that? By moving the decimal place over here to this spot right here, correct? Now I have 2.5. So I'm going to write that down. I have 2.5. And now, forget about this for a moment. We're going to come back to this, but just to make up for what we did here, we changed this from 25 to 2.5 times 10 to the first, because I moved it over one place. So this 10 to the first says that I'm moving it back one more spot back this way, because what's 10 to the first is 10, right? 10 to the first is 10. What's 2.5 times 10? 25. Okay? So that's all I'm saying here is I'm saying that I'm moving this decimal one place back to the right, which is going to give me 25, which is what I get if I take 2.5 times 10. Okay? So I've taken care of all this stuff that I've written right here takes care of what's happened right here. But now I have this 10 to the negative 5 that I have to deal with, so I carry that over and I write down 10 to the negative 5. So now my problem looks like this. 2.5 times 10 to the first times 10 to the minus 5. When I'm trying to figure this out, remember, scientific notation has to be greater than 1, less than 10, and it is. I have to have a times sign. I have to have a power of 10. So now I got to do something here. I have all of this, but now I have this 10 to the first times 10 to the fifth. When I am multiplying powers of 10, my power of 10 is going to stay the same, but it's my exponents that have to change. And when I'm multiplying powers of 10, then I have exponents. I simply add the exponents. So I'm adding 1 plus the opposite of 5. 1 plus the opposite of 5. What is the opposite of 5? Negative 5, right? So what's 1 plus a negative 5? Negative 4. That's my answer. Yeah. Does that make sense to anybody? Okay, does that make sense? Are we okay with that? Okay. Now, guys, if you'll notice, I have 2.5 times 10 to the negative 4, and I showed you this long way of doing it. Let me show you another way. Let's go back to our original problem. Let me change colors. Let me go back to my color. We had 25 times 10 to the negative 5. Well, let's do this. Let's take our 25 and add our decimal point this time and go 10 to the negative 5. And now let's take this to the negative 5. If I'm going 10 to the negative 5, this negative 5 means I'm going 5 places to my left. Do you agree? Because it's negative. It's a negative 5. So now we're forgetting everything we did here, and we're looking at doing this problem another way to see which way you like better. So I have 25 times 10 to the negative 5, and I know to put this into scientific notation, I have to get the number where it's greater than 1 and less than 10. But let me just take this 25 times 10 to the negative 5 and apply the negative 5 to the 25. And to do that, this is telling me that I have to go 5 places to the left. Do you agree? Because it's negative. And on the number line, negative is to the left, right? Negative is this way, positive is this way, 0 is right here. So I'm going to the negative 5 places. So look what happens. I go 1, 2, 3, 4, 5, and I put my new decimal point right there, and then I add zeros right here. Okay, so my new number is now going to be 0.00025, right? Now, to put this into scientific notation, I have to bring this decimal, just like when it was a 25, it was over here, I had to move it over here. Now it's over here, I have to bring it back over here again to make it greater than 1, less than 10, right? So when I bring it over to here, guess how many places I moved it? 1, 2, 3, 4. So it's times 10 to the fourth. But which direction, if I want to get it back over here, which direction do I have to go? Back to its original. Left, which means I'm going what? Negative, so I put -4. Same answer I got right over here. Does that make sense? Yeah. You guys get it? Are we okay? It can be a little confusing, right? Jacob, you're not saying anything. Are you all right? Okay, good. Josh, are you okay? David, where are we at? Well, because right now when we have let me clear all this out. Because David, when we have 25 times 10 to the -4, let's do this for a moment. We said that when we multiply 25 times 10 to the -4, our answer is going to be 0.00025, right? 25 times 10 to the -4 equals 0.00025. Let's do this. Let's take 25 and times it by 10 to the -4. So we're going to have 25 times, now to take 10 to the -4, we got to take 10 times 10 times 10 times 10, right? 10 times 10 is 100. 100 times 10 is 1,000. And 1,000 times 10 is 10,000, right? So if we take 25 times 10,000, hope this works. What do we get? What's 25 times 10,000? But we got to remember, this is to the negative, so this is -10,000, right? So 25 times -10,000 is what? -250,000? So if we wanted to move this, if we wanted to take this and move this is going to be very confusing. I'm not sure this is a good idea. This is like really going out on a limb to explain this. Is anybody with me so far? Because now you got to count your decimal places. You're not with me? You're okay. You know what? Let's forget this because it's really gonna open a can of. I thought maybe this would make it easier, but now that I'm doing it, I'm like, you know what? If you don't understand these other zeros are going to screw you up. So let's forget about all that. Let's just forget about all that. Okay. And let's go back to our problem that we had. We take 25 times 10 to the -4, and so David, what we have is we have our 25. Yeah, it should be -5, right? Was our problem originally -5? It was. Yep. Thank you. Originally -5. We take 25 times 10 to the -5, and we know that if it's going to be a negative number, we have to go to the left, right? We know it's going to be a negative number because 10 to the -1 is going to be -10. 10 to the -2 is going to be -100. 10 to the -3 is going to be -1,000, and so on and so forth. So anytime we multiply this number by a negative number, it's going to give us a negative number. It's going to give us a negative number. Do you agree? Okay, we were all okay with that? So, and my point that I was trying to make was, I don't know if I should. No, I guess I can't. I'm just going to keep on repeating it this way to see if it sinks in. We have to go 5 places to the left because this is a negative, and negatives go left. So when we go 5 places to the left, we go 1, 2, 3, 4, 5, and that's where my decimal place goes. Then we have to add zeros in each groove. So we wind up with 0.00025. But we have to put it in scientific notation. Scientific notation is a number greater than 1, less than 10. So we know that that decimal has got to go right here. How do we get it there? By going back 1, 2, 3, 4 spots. So our answer is 2.5 times 10 to the negative 4. So when we have 25 times 10 to the negative 5, what we're saying is 2.5 times 10 to the first, because we changed it, times 10 to the negative 5th. And then from there we have 2.5 times 10, and then we're taking 1 and adding a negative 5 to it, and we're getting negative 4. The same thing we have when we do it this way. Okay? Do you understand that? Okay? You got to keep on looking at this over and over and over again and doing the practice set and doing it over and doing it over and doing it over till it makes sense and finally clicks. I don't know of an easier way to do it than that. Let's look at the practice set and see if that helps a little bit. Yeah. I would say yeah, until you know how to do it, until you can do it in your sleep. And unless you're very, very comfortable with it, then no. But I mean, you know, take the shortcuts you take are going to haunt you later. If you do it in class and you understand it and you don't go home and look at it tonight, I will guarantee you tomorrow you'll not know how to do it. You're going to have to look at this. Unless you're just so comfortable with it, then, you know, that's up to you. But I would certainly at least look at it again tonight. I wouldn't do it over necessarily, but I'd look at the notes that we did from class today when we were doing these practice sets to make sure you understand it still. You know, Kirby, you know what I'm saying? Okay, so for A, we have 0.16 times 10 to the 6th. So what's our answer going to be? Here's what we do. You know, guys, the first step, we have to put this into a position where the number is greater than 1, less than 10, right? So how do I do that? I do that by putting that decimal right here, right? So I'm going to have now 1.6 times 10 to the what? Well, I have to show that that decimal was originally right here. So this measurement right here has to represent what I had up here. So I have to tell them that to get back to where I was originally, you have to go to the left one place. If I go to the left one place, it takes me back to 0.16, which is where I started. Do you understand that? Do you understand that, guys? That's why this is a 10 to the negative 1. 1.6 times 10 to the negative 1 is the same thing as saying 0.16. 1.6 times 10 to the negative 1 is the same thing as saying 0.16. Because that negative 1 is telling me I'm going to the left, going to the negative direction, one place. Do you understand that? Okay. Then my next step is to take the 1.6 times 10 to the negative 1 and then times 10 to the 6 that I originally started with. And when I do that, I end up with 1.6 times 10, but then I have the exponent negative 1 plus the exponent 6. What's the opposite of 1 plus 6? 5. The opposite of 1 plus the opposite of 1 is negative 1. Negative 1 plus 6 is 5. So my answer is going to be 1.6 times 10 to the 5th. Now, let me go back and show you the other way you can work this problem out and do it. You have 0.16 times 10 to the 6th. Okay? What you can do is take this 10 to the 6th and move that decimal 6 places. So I have 0.16, and I'm going to move it 6 places. 1, 2, 3, 4, 5, 6. My decimal's right there now. For every groove, I'm going to put a 0. Okay? So now, this is where I'm at. I'm over here. Now, I have to put this in scientific notation form, which means where does a decimal have to be? Where does a decimal have to be? Somebody tell me, Jacob. Between the 1 and the 6, right here. You see where I'm putting it, guys? Everybody see? Now the question is, that's where I just put it. How many places did I have to go to get it there? Let's count. 1, 2, 3, 4, 5. Does that make sense? Cam? Yeah. Are you like really overwhelmed, Cam? Don't cry. It's overwhelming. I mean, this is a concept that doesn't come easy. You have to really kind of work it. Kirby, you okay? Okay. Yeah, I mean this, if you get it, you get it. If you don't, you could almost want to like hit something. It could be very frustrating. It could be very frustrating. This is where you need like a rubber hammer to smack against the table or something, like a mallet they have for computers. It could be very, very... Who's confused right now? Okay, Cam. Keep on looking. Do you have a computer? Huh? Do you have a computer at home? Okay, this is being recorded, so look at it tonight. Until it kind of sinks in. Let's do another one. This will be our last one. We have 30 times 10 to the 5th. Okay? I'm just going to show you one quick and easy way to do this, the way we've been doing it all, the way we've been doing the second part of it. Hopefully it'll be easier for you. Look at, we got the number 30, right? Huh? 1 in 10. Yeah, but we have the number 30. So what I'm saying is we have the number 30, right? And we're going to multiply it by 10 to the 5th. Now, what that means is we have to go how many places to the right? Well, originally we started it has to go to 3.0. So we would write down 3.0 times 10 to the 1st, right? You agree? To the 1st? Because I have to go back to 30. And I'm timesing that by 10 to the 5th that I originally had. So 10 to the 1st times 10 to the 5th equals what? 10 to the 6th, right? So I have 3.0 times 10 to the 6th. Guys, okay, listen. I know you're teaching, but listen to this for a minute. Everybody watch this, even those that are with the tutor. I have 30 times 10 to the 5th. My decimal point right now is here. Would you agree? Everybody agree? Jake and Nick. Jake and Nick, I want you to watch this, Jake. Okay? Look up here. I'm over here. I'm over here. I have 30 times 10 to the 5th. My decimal place is right here. Even though they don't have one in the book, that's where it would be. Okay? So now I have to go 5 places. This is a positive 5, so which way am I going? To the right. So I'm at 30, and I have my decimal place here. I'm going to go 5 places to the right. 1, 2, 3, 4, 5. My decimal place is now right here, isn't it? So I'm going to add zeros for every one of my grooves. Now when I go back to where I have to be for scientific notation, how many spots am I actually going? 1, 2, 3, 4, 5, 6. So my answer is 3.0 times 10 to the 6th. Okay? Did you get that? Huh? What, Dave? Uh-uh. I'm taking these numbers to the right. So I'm positive, because when I get this 3.0, or I'm sorry, rather, I have 30 times 10 to the 5th. When I get done, I have to let them know that I'm going in the proper direction. And the proper direction that I was going is I had 3.0 a 3-0 point, I ended up with 3.0. So to get back to 3-0, I have to go one place to the right there. Plus, they want me to go 5 more places to the right, which is 6 places to the right. Okay? I'm going back to the left to get my answer, only to put it in scientific notation. But that's not how you count it. Are we okay, guys? Okay, listen, I'm going to save this and I'll put it on the blog tonight. Look at it. Look on the blog tonight. Put your first name on the blog. Sign in with your first name so I know you looked at it. And tell me if it helped, okay?